So we were discussing about the variance, like there they are using the terminology sample variance, and I told you why we can't find the standard deviation directly, because sum of the deviations is equal to 0. So always will get 0 as the answer. Divide by n will always give you 0. So to get rid of this issue, or to resolve this problem, what they have done is the same data will continue, but here we will take x minus x bar the whole square. So with this, what will happen? X minus x bar is, whatever. See, we will, it is not modulus also. Let's say the same data I'll take. Okay, I'll put it here. Mean is 30 minus 20 minus 10. Now x minus x bar the whole square. So with this, what will happen is become 400, 100, 0, 100, 400. Now you can total. It will become 1000. So sigma, this is sigma x minus x bar the whole square. So sigma x minus x bar the whole square divided by n. This is for population, but we are finding sample variance minus 1. Why minus 1? If this is the population, one out of that, one sample from the population has been taken out. If the number of observations in this entire sample, population is 10. If I take out one sample out of this entire population, this will become 10 minus 1, that is 9. So 9 terms are left over because one term is out. So this is called sample variance. Okay, now we can do a question based upon this and we can calculate. Okay, sorry, I was about to finish that, right? I didn't do. So 1000 divided by 5 minus 1, 4. So 1000 divided by 4, 250 is your standard deviation. Okay. Oh, no, sorry, it's variance. So standard deviation is root of variance 250. See, 200 squares are no 10, like 15 squares are 225. So your answer would be between 14 and 15. No, 14 and 15 and 16. Sorry. Why? Because 225 is 15 square. 256 is 16 square. So 250 lies between these two terms. So it will be 15 point something. That will be a standard deviation. Now I'll give you a question to calculate. Please do the calculation of that. The data is given to you as 30, 12, 25, 20, 23. You have to find out the variance of this. Fatafat, please. You have to do it fast. I'm just waiting. Okay, you're not doing. See, first you have to find out the mean. That is sum of the observations by number of observations. The mean is 22. Then you have to, x minus x bar, the whole square. Why we are doing this? We want to remove the negative signs. So 30 minus 22 whole square, 12 minus 22 whole square, 25 minus 20 whole square, 20 minus 20 whole square, 23 minus 20 whole square divided by 5 minus 1. So this is your variance. But we want standard deviation. If at all we want standard deviation, we need to do the square root of this. Now coming to what is this like 44.5. Let's see the statement. See, based on the mathematical theory behind statistical procedures, the use of the entire number of sample observations n instead of n minus 1 as the divisor, that means you are using to divide, in the computation of s square will systematically underestimate the population variance. Underestimate the population. So what they are saying is use of entire number of sample observations n instead of n minus 1 as divisor in the computation of s square. See, it is not like that. You will definitely take one sample out of the population. So you have to take n minus 1. Okay. That will be the proper measure. Now, this systematic underestimation causes the sample variance to be a biased estimator of population variance. So what they say is if you take particularly for small sample sizes, let's say this systematic underestimation, that means n instead of n minus 1 if you are taking, causes sample variance to be a biased estimator because you have taken one sample out of the population and still you are considering n. It becomes a biased estimator. See here. If at all you take n, it becomes biased estimator. If at all you take n minus 1, it becomes unbiased estimator. So if you get 44.5%, whatever we have got square, because if you are going to do 44.5% square, you are getting right. If you are going to do root of this, you're going to get standard deviation. Okay. So this can be interpreted as an unbiased estimator of population variance. That means this shows the variance in the population and very firmly without any element of doubt. Okay. So note that 44.5% square is this because percent square, 1 by 100 percent is what 44.5 into like anything you take 1 by 100 square because it's like this one, right? 1% percentage is like divided by 100. Any number if you want to make a percent, it is divided by 100, right? So that if you just take this 1 by 100 square, it is like 1 by 10,000. 1 by 10,000 is 44.5 into 0.0001. That is 0.00445. And you will get this value if you put the percentage returns in decimal form. Example, 0.30 minus 0.22 whole square. That is, if you like if you want this answer, let's say you have got this 44.5% squared, right? 44.5% squared. If you want exactly this answer, then every percentage you have to convert. This is 30%. So 30% will be 0.30. 12% will be 0.12, 0.25, and every time minus 0.22 you need to do. Okay, and then 0.30 minus 0.22 whole square you need to do. And at the end, whatever answer you're going to get is going to be this one. Okay, in this form. Better you find out this and divide by 10,000, you'll get the same answer. Okay. So we'll stop till here today. We'll continue. Okay, then or otherwise, let's go for the next question also and close this. Why? Because sample standard deviation also is there, right? Now, whatever we have found out is sample variance. If I do the under root of that, see, they have done whole power 1 by 2. I get the sample standard deviation, that is 6.61% or 6.67 divided by 100. 0.0667 is the standard deviation. Okay. So this is what is the end of the class today. Tomorrow we'll continue from coefficient of variation. Fine. I think tomorrow we can close this chapter. Tomorrow is the last class for this chapter. Thank you.